Leetcode problem 3008. Find beautiful indices in the given array 2. So for this problem, we are giving a string s, and we are also giving two strings a and b, and we are also giving integer k. And let's just check what we're gonna do for this problem. Yeah. So we are giving those strings and an integer k, and index I is beautiful if I is in the range is more than equal to 0, less than equal to s dot length minus a dot length. Yeah. So this means, for example, there is a mine. It must be inside of the string. So for example, this mine. Yeah. Yeah, because this length minus a's length, it must be inside the range. So this is exactly inside the range. So for example, the index is going to be n minus 1. It is exactly inside the range. Yeah. So for example, this is mine, and I have an index. Or from some other places, I also have an index for this mine. And similarly, for the b. So for b is a square rule. So at some places we have a square rule. So for example, at some other places we also have a square rule. So what are we going to do for this problem? First of all, let's just check the index of I. So how many indexes? It's going to be 2. So from index 16 and 33. So this is 16 and this is 33. So the second step is that we're going to find the index for this string b, square rule. So how many of them? There are 2. So the first one going to be the first one going to be index 4. It is here. And the second one going to be at index, let me just check. Yeah, at index I forget where it is, but it seems it is here at index 18. So the second one is at index 18 for the square rule. So it is here. Yeah. So what are we going to return? We're going to return the array that contains beautiful indices in sorted order from the smallest to largest. So we only need to return the indices for string A, not B. Yeah, even it didn't tell us about that, but we should be know from the examples. Yeah, I think it should tell us, it should return the array that contains beautiful indices in sorted order from the smallest to largest of string A, but it didn't tell you about that. But you have to guess. According to the example, actually it is for A, not B. Yeah, and you can also check here. This A equal to string A, and the index is gonna be 0. Yeah, because actually it is only for string A, not string B. Yeah, I think the question should tell you about that. Don't let you guess something. Yeah, because guess is not so good for such kind of a question. It should directly tell you it should be for string A, not only string B. But it didn't tell you about that, so you have to guess. Yeah, so now if we guess it is the string A, so it's going to be the 16 and the 33, it's going to be the final return. But if we can get all the indices, so for example, indices for string A and all the indices for string B, we can find if it meets the conditions. So for example, the first index is going to be 16. Is that okay? We can choose 4 or 18. It is both inside the range of 15. Yeah, because the 16 minus 15 and 16 plus 15. So for this 4 and 8, it is both inside. We can choose either one of them. It is okay. Yeah. So definitely this is 16 works. And the second one going to be 33. So for this 4 it didn't work, but for this 18 it works. Yeah, because the 33 minus 18, it is less than 15. So definitely it works. So it means we're going to return 16 and 33. So this means for this indices A, as we are going to put it in sorted order. So definitely, if we are going to check it, we can make it in sorted order. And also, we can make the index B for this array in sorted order as well. Yeah, because this is easy to make. If we use the KMP algorithm, basically we are going to check all the string matching for this string A and string B. Basically, we can get an array A for the indices for string A and all the indices for string B. Basically, we can get that. And then we can use the binary search, because for this 16, we can use the binary search to check if there's gonna be a value would be more than and equal to 1. If we can find that value, it is still inside of the range of 15, definitely we're gonna get this index. And similarly, we can check the next index. Yeah, so first of all, we're gonna use the KMP, and secondly, we're gonna use the binary search to solve the problem. Yeah, now, if we've decided to use KMP, let's just define our next array. So this is gonna be just some template code. So for me, I'm gonna write it like this. I'm gonna prepare a -1 as my dummy place for the next table for the KMP. So for I in range length of the string's length, I'm gonna use a while to check while z more than equal to 0, and si not equal to sj. So I'm gonna update the j to the next j. I'm gonna use the next table, and after that, z gonna plus equal to 1, and next array gonna append this j, and after that I'm gonna return the next array. Yeah. Now we're gonna use this kind of next array to find all the indices for string A and string B. So for example, for this mine, I'm gonna find 16 and 33. How can I find that? Yeah. So I'm gonna define another function to find that, because definitely I'm gonna use I'm gonna call the function 2 times. The first time gonna be this string A, the second time gonna be this string B. Yeah. But before that, let's just calculate the next array. So the next A and the next B are gonna be equal to the next, and inside it's gonna be the pattern. Yeah, so it's gonna be this string A, and the next function gonna be this string B. Yeah. Now let's just check what is the next A and what is the next B before we calculate all the indices for string A and string B. Yeah. Let me just return an empty array. Yeah, as we can see, currently we get some return. Yeah, so this is for string A, because this is mine, and this is the next table. The first place is -1, and then it is a 0, 0, because there's no duplicate. And the second one gonna be square root, so the first place will be -1, and then 0, 0, because there's no duplicate for the suffix equal to, for the prefix equal to the suffix. Yeah. But maybe we can also check the second example. So yeah, it is also still okay, because for this A and this A. Yeah. So this is for calculating the next table of string A and string B. So AB basically it is a pattern. Yeah. Now the second step is that we're gonna check all the indices for string A and string B. So let's just define a function. So I'm gonna call it check. So inside the check, basically I'm gonna use the I'm gonna use a string s. I'm gonna pass the next array. Yeah, so here this next gonna be next A or next B. I will pass it later, and this s I'm gonna pass it as the string. Yeah. Yeah. Now let me just use the same code. Maybe I would to copy some code from the next table, because it is just similar. Yeah. So for I in range length of the s, but this s is for this string s. But this s is for pattern A and B, yeah, and we should understand about it. And then I'm gonna check the index j, but before that, I need to define the index j. So before that, j equal to -1, but here I need to define this j equal to 0. So while j is more than equal to 0 and si not equal to, yeah, this is a si should not equal to the pattern. Yeah, it seems I need to define the pattern instead of the S. Yeah. So here I'm going to use a pattern. So this pattern basically is going to be A and B. Yeah. So I'm going to use a pattern and the next table because the string going to be fixed from here. This is going to be a global variable. Yeah. So if Si not equal to the pattern, so z going to be equal to z dot next and z going to plus equal to 1. And here I'm going to check this j. So if j equal to the length of the pattern, so it means I've already found one. So I'm going to put it inside of the result array. So the result array gonna append the index. It's gonna be I minus j plus 1. Yeah. So from here, I'm gonna define a result variable, and finally, I'm gonna return this result. This is basically the table. The result is for this array and for this array. Yeah, basically. Let me just check if this result is okay. Yeah. After I put 1 inside, if there's only one index, I need to have a return, or I need to break it at least from here. But currently, I need to check all the indices for this string A, all the patterns, all the pattern matching for this bind. Definitely, it's going to be an array. It's going to be from 2 places. Yeah, I need to find this 16 and 33. So this means for the J, I need to use the next table to get it to the next j. Yeah. Yeah. So in this way, I can find all the indices for this string A or all the indices for this string B. Basically, this is the pattern matching. Yeah. Now I want to check if my check function is okay or not. Yeah. So how can I check that? I just need to pass it. So I'm gonna use maybe array A. Yeah, I'm gonna use array A to call the function, and array B to call as the final array. So array A gonna be the check. So I'm gonna check with string A and the next table for this next A. Yeah, and similarly I'm gonna call the check function with string B and its next table, so it's going to be the next B. Yeah. So now I want to print out what it looks like if it is similar like what I expected, like this one and this one. Yeah. Basically, if I can calculate like this one and this one, I can directly use boundary search to get the final result. Yeah. So let me just check what it looks like for this array A and array B. As you can see, it is 16 and 33. This is 4 and 18. It seems my calculation is right. So we can directly compare from here. Yeah. So this is 16, 33, 16, 33, 4 and 18, 4 and 18. Yeah. Well, basically, this kind of code, you need to have some previous knowledge of how to calculate this before. So the basic idea is how to get this array A and this array B and then use boundary search. And this is just a template code to calculate the next array. And this is what we're going to use this template code next table to produce all the string matching, all the indices for pattern A and all the indices for pattern B. And this is also similar like a template code. So you need to be familiar. Maybe your code is different from mine, but at least you should know how to calculate all the indices by using the next table. Yeah, because up to now everything is just on time. It is linear time. So for this one, it is on plus n, and for the next table, this is for the next table, this is basically on. Yeah, so currently it is just linear time, so everything should be okay. Now we're gonna use the boundary search. If we are going to use the boundary search, basically it's gonna be n log n time. So it means this value times log this value. Yeah, basically. Now we're gonna use boundary search to solve the problem. So I'm gonna prepare an answer as our final result, and I'm gonna check all the number inside array A. Yeah, actually it is all the indices inside of this index A. Yeah. So for any number inside it, I'm gonna use boundary search. I'm gonna check the index. So J gonna be equal to bisect. Yeah, it's gonna be bisect left, because we want to find a value. It's gonna be more than and equal to the current value. Yeah, and we're gonna use the array B, and we're gonna use this number for the bisect left. Yeah, but currently this number needs to minus 15. So for example, if we are going to check the first value 16, and we need to find a value, and we need to find the index, it's going to be more than and equal to 1. It's going to be 16 minus 15 minus this k, it's going to be 1. We need to find a value, it's going to be more than or equal to 1, and this 4 is going to be more than or equal to 1. This means definitely it works. So we're going to put the 16 inside the array answer. Yeah. So here going to be n minus k. Now we are going to now we are going to check the distance for this j. Yeah. So we are going to check if the absolute value of n minus array b with the index j, we are going to check this value. So currently this n is 16, and this value index is going to be 0, it's going to be 4. If 16 minus 4, it is 12. It is less than or equal to 15, the absolute value. If it is less than or equal to k, yeah, basically we need to put the index inside the answer. It is this number n. Finally, we're gonna return the answer. Yeah, so this is the basic pattern, I think. Yeah, now let me just run it to have a check if it works. So the index goes out of the range for the boundary search. This n minus this j. Yeah. So what about let me control the j? If this j is less than length of array b, let me just control it, and it is inside of the range. I want to put this value n inside of the answer array. Yeah, now as you can see, it works. And now let me just submit it. Yeah, now as you can see, it works, and it's pretty fast, and it passed all testing cases, and the time complexity gonna be dependent on here. So it is n times log m. So n gonna be the length of the array A, m gonna be the length of the array B. Basically, it is 10 to the power 5 times 10 to the power 5. So here, we need to control this index j, basically. So it means if the index j equal to the length of the array b, it goes out of the range. Basically, we don't need to check. Yeah. So for some testing cases, maybe let me use an example. Yeah, so this is 1633. This is okay for this 4 and 18, but let me use some edge cases. Yeah, to check. We have to check that this j should be less than the array b. If it is equal to the array b, what's gonna happen? Yeah. So currently, if we are going to check this 16, but this array b gonna be something like maybe -1 and -2. Yeah, this is just an example, or maybe I'm gonna use some other examples. Maybe this index gonna be 18 and this gonna be 33. So here I'm gonna use 1 and 2. So what's gonna happen? So this 18 minus the k for this example 15, it's gonna be 3. Yeah. So basically, we are going to find a value that's going to be more than 3, so it's going to be this number 4. Basically we are going to find a value that's going to be more than and equal to 3. So this is 1, this is a 2, and 3 going to be here, so it will go out of the range. Yeah, this is why we have to check that. Yeah, for this 18. Maybe the first one is like 15, so this 15 works, but for this 18, for this 1 and 2 it didn't work, and 33 for this 1 and 2 didn't work, so we have to check that. So this is why we have to control it. Yeah, it must be inside of the range for the index j, and then we're going to check if it is still inside of the range minus this number. Yeah, so we want to put it yeah, let me just check. This is a number, and this is the binary search. Yeah, we need to check this number. We need to check the first number. If the first number meets the condition, basically we don't need to check all other numbers, because this is this array B with this index j. This is going to be the closest number. We need to always check the closest number. This is why we're going to use a binary search to speed up. Otherwise, it's going to be n squared. Yeah, this is why we're going to use a binary search. We're going to just use a for loop and then binary search. We just need to find this number. Yeah, let me continue to use this example maybe. Just go back. Yeah, so this is a 16, and if we are going to check this 16, definitely 16 minus 15 is going to be 1. We want to find a number that's going to be more than or equal to 1, and this is going to be the smallest number more than and equal to 1. It's going to be this number 4. Yeah. Now I'm going to use this number minus this 4. So the 16 minus 4, it is 12. It meets the conditions. Yeah. So if it meets the conditions, I'm going to put it inside. If it didn't meet the conditions, I will not put this number n inside the answer array. Yeah. So for this 33, it still meets the conditions because I can still find 18. So what about for the next number if it is a 60? If it is a 60, definitely I cannot find anything. So what are you going to do? Because here I didn't find anything, so I didn't put it inside. Yeah. So I hope everything should work. Yeah, so this is why it works. I think I've already submitted it to prove that it really works. Yeah, I think that's all for it.